so it's just after it.
Okay.
Alright, pulling it open now. I got 1 and 2.
Nice.
Alright, a hypothesis test consists of 2 hypotheses, a null hypothesis and an alternate hypothesis. Which one represents the status quo?
I think it's the
That's the null hypothesis. Is the,
Yep, statement of the
that's what I
status
was
quo.
thinking. Equality, that's
Which hypothesis involves?
alternative, isn't it? No. That's the.
I think it's right here.
No,
It's the null.
no,
as
the
well.
null as well.
It is?
Yeah.
If you go up to right
Oh, okay. So I was just to confuse the crap out of you.
When computing this, or the p-value is probability of obtaining a sample statistic at least as extreme as the one that was actually observed. When computing this probability, which hypothesis do you assume will be true?
here.
It's is it?
Let me check.
Assuming the null hypothesis is true, what is the probability that we would observe a sample mean is extreme or more extreme than the values? If we observe this probability, it's called the p-value. So be or null again.
Okay.
Alright. Suppose the null hypothesis H whatever. Use the information to answer questions 6 through 8. Which of the following represents the alternative hypothesis for a detail? Would it be that it doesn't equal 10?
I don't know. It's sharing stuff.
Mean is greater than or is less than 0 is all that it states.
Yeah.
Alternative
right here.
hypothesis is equals 1 to it.
Yeah. So your null hypothesis that it equals it.
And yeah, that makes sense. Alternative is that
Or for a two-tailed? Hang on.
Oh, two-tailed does not equal.
Yeah, so two-tailed is
right
not
here.
equal. Less than would be your left tail, and your right tail would be greater than.
Okay. That makes sense. So then it's the equals for just.
So the outcome of a hypothesis test is determined by comparing the p-value to the level of significance, or alpha. Is that what that is?
Yeah, sure.
Uses information for questions 9 and 10. Which relationship would result in failing to reject the null hypothesis?
Which would be. Why do they do that? Why don't they just say rejected?
Failing to reject. P-value was
Significance. If the p is low, reject the null. So would it be less than?
yeah, but it's less than Z or the
Or would it be less than the level of significance?
yeah.
It's small enough to reject the null hypothesis. This number is called the level of significance and all is often denoted by the symbol. Oh, I was right. It is alpha. Yes.
So which one is it that it's?
It's less than.
So
I
it
was
would be
confused
less.
with
Would it be less than the alpha or less than z? So
I don't know where Z came from.
Z is just
because you're
I feel like they just tend to throw stuff in there. Like,
well because it's saying that the level of significance is that number if p is small enough. Is what I'm getting from this, right?
yeah, so the p-value is small enough to reject.
Oh, if p is less than alpha, we reject the null. I
Okay.
read it right there. Oh, get back up there.
So it's the bottom one.
What relationship
That's, oh, p-value is less than 1. Yeah, I see.
would
Yeah, it's-
result in failing to reject the null? So that's not rejected.
Yeah.
Okay.
And
The
then
next
you do the
one.
opposite.
Oh my
so
gosh.
did you get that for so it's
pretty
yeah,
much hard.
and this one's smaller.
It's so the top one's greater than A, because that would result in famous. No, this one's greater. Yeah, you're back. Because if it's less than A alpha, you're gonna reject it. If it's greater than, you're not.
Okay.
Okay. The insurance company is reviewing its current policy rates. When originally setting the rates, they believed that the average claim was about 1,500. They're concerned that the true mean is actually higher than this. All right. So which of the following would be the appropriate alternative hypothesis? So alternative would be it's greater than, right? Because they're believing that it's higher than that. So your regular one is H equals 1,500.
Yeah, that's
Right?
concluded. Yeah.
Would be the appropriate null hypothesis.
Is it equal? Yeah.
Insurance company randomly selects 40 claims and calculates sample mean of 1650. The insurance company assumes the distribution of sample mean is normal. Is this a good assumption? Yes, because it's over 30. What theorem or law justifies your
Central limit
answer?
theorem.
Which is,
Oh no,
it's
it's law of large numbers. Isn't it? Yeah, because sample mean is normal. Remember that.
which of the following is the test statistic as defined in plus?
I think it might be N.
The test statistics is
As defined in this lesson.
isn't that X? I think that's
I saw N right here.
Well, you have N, you have your egg. So test statistic. Let's just take that out. So your Z-score, is that what it is?
No.
It says mark the test statistic and p-value on a graph.
Oh, well,
so
just
it
look at
says
the answer.
we need to determine how far X is from the. Since we know the standard deviation in this case, we can use a Z-score to determine if X is far from the assumed
So your
value.
test
This is called the
statistic
test
is
statistic.
your Z.
Yeah, it says it right here.
Oh,
I just put in test statistic and searching through the thing for it. Alright.
the historical mean of sales at C at a grocery store is 150 with standard deviation of 40. The store manager suspects that the average has decreased. She set the hypothesis to test following hypothesis. To use the level significance alpha equals 0.05. She takes a simple random sample of 36 sales receipts from her store and computes that X equals 144.
So find the Z-score.
We got 0.5 is the.
144 minus 150.
Do we have a standard deviation? Oh, standard deviation of 40. Yeah.
40.
Divided by 40.
The mean is 150.
So negative 0.15 is what I got.
I mean, that's a common.
Are you using the population with that? Because we have 36 sales receipts.
Nope. Sure didn't.
So it's
Divided by, it's
144 minus 150 divided by 40 divided by the square root of 36.
which is 6.
Yeah. Standing outside with the dog, they start flapping up
Dude,
in
it's
the
really
face.
outside.
I didn't at first. I didn't realize. I was like, "What is he hitting me?" I was like, "Wait, it's
0.9.
around
says
three
round to
decimal
3.
places."
So I don't know. Because 144 minus 150 is negative 6. So you have 40.
Negative 6 divided by 40, right?
Well, no, because you're going to do 40 divided by 6, which is,
Wait, 40 divided? Oh, yeah.
so 40 divided by negative 6 is negative 6.66666.
But then you divide that by 6.
And then, well, you do 6 divided by that, right?
Okay, so we have.
Because this is your bottom. And so you have 6 on your top, so 6 divided by 6.6666667 is 0.9. I mean, if you want to get like super technical with it, you could do like 0.899 whatnot, but it all goes up to 0.9.
Sweet disposition. Ready for it?
What?
Okay. Yeah. So
I was
we
gonna say
have.
technically it goes that, but you round it to 3 decimal places, so that goes up, and
So what
you
is
get
it?
0.9.
Yeah, I did it out. That.
So 0.9000.
What
do
is
you
the
get
p-value
p-value?
associated with the z-score of the previous question?
So your
Oh.
p-value
It was. I think it was
Is
in
the
that.
area in the tails beyond the or positive or negative z in both the left and right tails? Standard
open.
Yep. So what is it? 0.9?
0.9. Yeah.
0.3681.
3681.
Yeah.
So
just
368. What inference would you make about the null hypothesis for this problem?
I would.
It's got a very low z-score.
Your p-value.
If it's lower, then you would
So-
reject the null. Because
Right.
that was in the answer right above it, what we just had.
Oh yeah.
So your p-value is less than your null, so you would reject it.
And it's,
Okay,
I think
yeah.
you can say right here as well.
Rejecting.
Unless it's equal or you reject.
Okay.
There are two types of errors that can be made when performing a hypothesis test. Which one involves rejecting the null hypothesis when the null hypothesis is true? Two, isn't it? Oh no, it's check one. It says in the book, type
That is
1
in
error.
reality true, yeah.
Yeah.
So type 1.
A researcher decided that instead of using a level of significance of
Wait.
alpha equals 0.05, he will use alpha equals 0.01. Which one following this?
Would
I
you,
think
wait,
we may need to use
I was
the
gonna say-
other.
I was going to say, would you reject the null on 18? Or would you fail to reject it? Because your level of significance is 0.05. And so it's your p-value is less than that, not your z, you know? Does that make sense?
He's low reject the
I think
null.
we might be using the wrong
Well, like,
equation.
If the
with
p-value
your
is less
p-value-
than alpha, we reject the null hypothesis.
but
And
it's not,
alpha is 0.05.
it's not less than.
It's not, so we fail to reject the null. Yeah.
And so that would still be a
Yeah.
type 1 because
Yeah.
in reality.
Yeah.
Okay. Cool. I'm like, wait a second, that doesn't seem right. I'm like, we need that for a minute. Okay.
Okay, so if it was this,
If it was this,
it'd still be the same answer. I feel like it has to do with this though.
well, this is the number that you're associating with this. 'Cause
Yeah.
if this is greater
But-
than or less than the level of significance,
I feel like if you're saying if they changed it, that would change this.
the level of
What?
significance.
Oh no, it's still below.
No, your z-score is still.
Yeah.
So it'd be the same answer as the other one then.
But it could result in a type 1 or type 2 error being committed more, or I mean, it might be more scientifically valid because you're using a smaller significance. So,
Okay, we choose alpha to be some small number so that the probability of committing a type 1 error is low. The most common value for alpha is alpha equals 0.05 is equal to 120. So when the null hypothesis is true, there's 1 in 20 chance that we will reject at the 0.05 level of significance. Other choices for that include 0.1 and 0.01.
yeah.
Typically, if committing a type 1 is undesirable, why can't we let a be equal or alpha be 0? This would make it impossible to commit a type 1 error.
So the probability of a type 2 error would go up, right? Because it says
Yeah.
probability of committing a type 1 error is very
Very
small. The
small.
probability of committing a type
Large.
2 will be large. So
Yep.
type 2 error will go up, will increase.
Probability of committing a type 1 error if alpha equals 0.05.
I don't know why that page isn't working.
No.
And you press it.
No, but then I can go here and I used to be able to scroll on it.
Weird.
So how do we compute the probability?
Trying to remember.
Oh, it says it's 1/20, and then when it's using this,
It's equal to 1.
It's okay.
So if A equals 0.45, so would that just be 1/20? Or
Says here, so if analysis was done at a alpha equals 0.01 level, what is the probability of committing a type 1 error? There's about a 1 in 100 or 1% chance that there would be a type 1
oh,
error.
so it's 5%.
so do you put 5% in, or do you put 1/20?
Yeah, because there's two
Because
different things.
I was gonna say I don't know.
Well, it's the same thing.
Yeah, but how does he have it set up to
That's
mark the right ones?
in the homework or in the prep, it was percentage, right?
Well, it won't let you put a percent sign in, so I'm gonna put 0.05 because that's 5%.
You can't put a percent sign in on yours either.
Mhm.
I guess we can.
And you can't do 1/20,
Yeah.
so you just have to do just 0.5 or
All right.
0.05. So it won't let you do